Hello and welcome back, everybody. This is Noah again, and here we're going to run through the solutions for the now you try problems on how to evaluate a function when that function is defined as a graph, and then we'll look at how to solve function equations when that function is defined as a graph again. Once more, the full explanation for how this is done is given in the previous video with the examples, so if you haven't watched that, please go back and do so. The problem one that we're given is that the graph of f of x equals y is attached in this image. It's a straight line with a downward slope. It has an x-intercept of -1, 0. The y-intercept is hard to tell. We're going to approximate this. This is probably about 0, -0.2, give or take. We see a couple other points that are on the grid lines. We see -5, 1 is a point on the line. We see the point 3, -1 is a point on this straight line. And I think we can actually do a little bit better. It looks like that y-intercept is that this slope is down 1 over 4. So if we're going just over 1, we've only gone down 1/4. So there is a way of doing that a little bit more precisely here. That's an exact value now. So we want to read this graph and be able to tell what is f of -5, what's f of 3, what's f of 0, f of -1, and what's f of 4. So f of -5, we look along the line and we see there at the left end of the picture, we can see that when x is -5, the graph has a y value of 1. So that's the output of the function. 1 is the output of the function when the input is -5. When the input is 3, we move along the line until we get to a point that has an x value of 3. Here we see that the point that has an x value of 3 has a y value of -1. So the output of f when 3 is the input is -1. F of 0, if we input 0 into this function, the output, the y value, is -0.25. or -1/4. And we see that as the y-intercept. That's where x is 0. When x is -1 and we move along the line until we get to a point that has that x value, we see that the output is 0. We have the point -1, 0. Last, we want to evaluate f of 4. So I move along the line until I get to a point that has an x value of 4, and I try and determine what the y value is. Here it looks like the y value is probably -1.25, right? -1 1/4. So I'll go ahead and write that this equals -1.25. That's it. That's all we're doing for this problem. No other questions here. All right, let's move on to the next one. Pause if you need to, but I'm going to move on to the next one where we look at solving equations given a graph. So here we're given the graph capital G of x equals y, which is a downward facing parabola with a vertex of 1, 3. The vertex of a parabola is the turning point. It's where it switches from going up to going down or going down to going up, right? It's the top of the hill or the bottom of the valley. And it has a y-intercept of 0, 2. It has a mirror to that across from the vertex line, or the axis of symmetry. There's the point 2, 2 on this parabola. Other nice whole number points are 3, -1. And the point -1, -1. The x-intercepts are really approximations here. There's no nice numbers. 2.7-ish, 0, and then -0.7, 0 looks like the other x-intercept, and those are approximations here. So we're looking at solving the equations capital G of x equals 3, capital G of x equals 1, capital G of x equals 0, capital G of x equals -1, and capital G of x equals -5. Let's look at that first one. Capital G of x equals 3. So we look for an output of 3. That's our y values, or the outputs. And we see that the only point on this graph that has a y value of 3 is the vertex, the point 1, 3. So we can write the solution set is the set containing the number 1. That's it. It's the only solution to where the output of this function equals 3. All right, the next one is saying, where does the function output a positive 1 value? So if I look at a y value of 1, I try and find points on the graph that have a y value of 1. These look like approximations, maybe 2.4 comma 1, and then negative 0.4 comma 1. Those look like the points where the y value is 1. And so we'll write the solution set is the set containing, and we'll just leave those approximations, negative 0.4 comma 2.4. Next, we want to solve capital G of x equals 0. Here, that's the output is 0. That is, the y value is 0. On the x-axis, right? So those x-intercepts are where we get an output of 0. So those x-intercepts have x values of negative 0.7 and positive 2.7 approximately. So I'll write the solution set is the set containing negative 0.7 comma 2.7. All right, part D, we have capital G of x equals negative 1. Here I've actually already labeled these points on the graph. We have the point negative 1 comma negative 1. That has an output of negative 1. And then the point 3 comma negative 1. So when x is 3, the output is negative 1. So we can write the solution set is the set containing negative 1 comma positive 3. We've got one more here. We want to know, when does capital G of x equal negative 5? This is something where we're going to need to extend our parabola down a little bit, because if we're looking at negative 5 as an output, as a y value, and I try and find the points on the graph, they are a bit below those arrows that we'd had there. So we'll move out here to the right, and we see that this is about 3.9. I'm going to approximate this at, maybe 3.8 comma negative 5. If you used 3.8, that's totally fine. Negative 1.9 comma negative 5. If you used like negative 1.8, also probably fine there. It's really hard to tell, right? We're just doing this visually, so we're just making our best estimation from what we can see with our eyes. So I'll use the negative 1.9 and positive 3.9, and write that the solution set is the set containing negative 1.9 and 3.9. Close that up. All right, that's it. That is all of the problems for these Now U tries. That's the end of this mini module 2a. You're done. Go ahead and finish up these Now U try problems, have them ready to talk about in class, and have a great rest of your day. We'll see you in the next one.